Yeah. Good evening, students. So let's wait for some time for others to join and then we'll start the session. We are waiting for others to join. It's just 46 students. Once few more students join, we'll start the session. Okay, students? Okay, we'll wait for max 2 more minutes and then we'll start the session. Now, those who are coming too late, we cannot hold the session for them for too long. Let's wait for just max 2 more minutes. If they don't come, we'll start the session with the number of attendance that we have. Okay, so now let's start the session. I guess as the days are passing, people are getting lazy. So we are on our DSA series, and today is our fifth day. We will see a couple of array questions, and then we'll go with the linear search, binary search, of course, uh, sliding window, and then sorting techniques. That is going to be the agenda for the day. Just waiting for the IDE to open. First, we'll code for an array. We'll see if the array is sorted or not. We should just return true if the array is sorted, or else false if the array is not sorted. So here we are. And byte Excel DSA. So I'll be making one more package here. I would name it day 5. And this will be coding now. So sorted array. Let's see. It's going to be array. I'll give you an array and I'll give you time to find out. You just need to return, is this array sorted or not? Let's take an integer array. We have numbers in ascending. Let's keep it very simple. 1, 2, 3, 4, 5. So this is of course sorted array. So it should return true. Logic you need to write. You need to write the logic to find. If this array is sorted. Of course it is sorted. You should get an answer yes. True. Is the question understood, students? Any doubts in question? Can I get some responses in the chat box? Yes, no, no. Okay. Not understood. Okay, fine. You need to find, is this array sorted? See, if I put here 8, 1, then the answer will be false. This array is not sorted. 8 is bigger number. It should be after 6. But if I put here 1, this is sorted. The answer should be true. Now is the question understood? Thank you. You need to find the logic for it, write the logic for it. If not, of course, we'll do it together. It's a simple question. It's asking sorted array. The array is sorted or not. Is it sorted in ascending order? It is sorted right now. You just need to find out. You need to use a variable Boolean and try to find out, is the array sorted or not sorted. I give you 3 minutes of time to do it. Write the code for it. If you are not able to do, of course, we'll do it together. But at least you can try. The question is to find out, is the array sorted or not sorted. Good, Khushi. Yeah. Good, Jatush. Good, Neha. Let's wait for others also. If they are able to solve well and fine. My whole aim is that you should be able to do it. If you are not able to do it, of course, we'll do it together. But then once we move to complex question, these simple questions will be very more complex. Fine. So now just one more minute and then I'll start with the solution. Of course, we'll be using a for loop, a boolean, everything. Fine. So now let's start with the solution. I'm making a method static. This is a boolean. It will either return true or false. Is sorted is the boolean value. It will take an integer array. We have it already on top. We'll take that as an argument. And I'll write a for loop for int I is equals to 0. I is less than array dot length. And we are going to increment the I. And then we are going to have a if statement. If array of I, if each element inside the array is greater than array of I plus 1. If that one is greater than that, then you return false. Because that will not be a sorted array. What I'm doing is I'm telling simple way that if array of I is greater than array of I plus 1, you return false or else you return true. If every element at the left is smaller, then you return true. If one of the element is greater, then you return false. Now, there is no fixed method to it, but I feel this one is a bit more comfortable when it comes to logic. So of course, system.out.println, and I'll call this method here. So I'll just tell is sorted, calling that method, and array. So now this one should return true because each element at the left is smaller than the element at the right. And it says array index out of bound. That was not expected. I need to do length minus 1. My bad. Because length starts from 1 and index starts from 0. True. But the moment I make this number as 5, so 5 is greater than 4. So this condition here will not be met. It should return false. See, it return false. But then again, if I write here 1, 1, 2, 1, again it should return, I guess, false. If I write here 3, this one should return true. Is the question and logic understood? Of course, we all have our own logics. I'm not telling you your logic is not correct or my logic is only correct. That is not the correct scenario. It's just you should have. I got some answers in the chat, and again, they were also good answers. Now it's practically impossible for me to go through all the possible solutions. We are just using a for loop And then we are telling if ARR of I is greater than ARR of I plus 1, I plus 1 means we are moving to the next element. Then you return false or else you return true. Simple. So now, should we move to next question? Any doubts in this? Move to next question. Okay, Abdul, sure. So now, simple thing, no inbuilt methods. And yesterday, I guess we were supposed to do it, but then we did not. So reverse an array. We were of course going to do it, but then most of the students said that we'll go with the theory part. So we went to the theory part. So here we have an integer array. And that is, let's take some numbers like 6, 4, 3, 1, 8. Yeah. So it's going to be an integer array. My bad here, I did not write array symbol. Fine. So now when you reverse this, the answer should come. Don't use inbuilt methods. 8, 1, 3, 4, 6. You can see reverse an array. So this should be the answer. You need to write the logic for it. We need to reverse an array. Please try to do it. Yeah. If you're not able to do it, we'll do it together for sure. Okay. Okay, let's try to do maybe this approach. For int I is equals to I'm not really sure this one will work or not, but I'm trying it. And I can see some chats here. Okay. Okay. Abdul says it will work, and same answer I got from Ridhima as well. I was thinking of swapping it. Okay. Yeah, it did work. Okay, fair enough. So now let's come here, and one of you was asking yesterday for recursion. What is recursion? Anyone any idea? Okay, recursion is basically when you repeatedly do an activity to get a result. Again and again, you try to repeating a particular function several times. Exactly, Chatush. When you repeatedly do certain activity to get a result. For example, we saw Fibonacci series. A function, yeah, fine. A simple question. Factorial, yeah. Factorial can be a question for recursion. Exactly. Yeah. Repeated loop for exactly. Yes, Piyush. How many of you know what is factorial? Yes, function calling itself. Yeah. Factorial of a number. What is factorial? Anyone any idea? Exactly. The factorial is, yeah. Factorial is an example of recursion. So maybe if I ask you for factorial of 5, you need to write a code for factorial of a number, maybe for 5. So it will be like the preceding numbers 5 times 4, 20, 4 times 3, 20, 2 3s are fine, 60, 60 into 2, 120, 120 into 1 equals to 120. So you have 120. So the code that you write here will be factorial. Sorry, will be recursion. Sorry. Is recursion understood? What is recursion? Of course, we'll be doing it in coding way also. But then this is just the theory part. Is this correct or not? Those who know it, they can correct me if I'm wrong. I'm pretty sure it is correct. Exactly. So recursion, it's a simple example of recursion. Of course, complex examples can be much more depending upon the type of the question that we have. So you need to write the code for factorial. Okay, theory of recursion is not understood. Okay, 1 minute. Fine, fine, fine. Okay, let's come here and recursion. Recursion is basically a function calling itself. Recursion is a programming technique where a function calls itself to solve a problem by breaking into smaller, similar subproblems. It requires a base case to stop recursion to provide infinite loops. For example, factorial. Here you can see Fibonacci series. Fibonacci also we did. So basically, you call yourself only. For example, you use a for loop, and then of course you are traversing. Traversing means going through the thing, and then of course exactly the function that calls itself spurti, you said correctly. So basically, when you write the code for factorial, you are doing recursion only. You are calling again and again 5, again multiplied by 4, again by 3, again by 2, again by 1. So you are using factorial behind the scenes, sorry, recursion behind the scenes. If you see introduction to recursion, the process in which a function calls itself directly or indirectly is called recursion, and the corresponding function is called recursive function. So of course, there is recursively you are adding, you are doing recursion all the time. So basically, when a function calls itself again and again to get the answer, that is called recursion. But then you should get an answer, or else you will go an infinite loop. So let's try to code that now. Once we code it, you will get a better idea. Of course, what you need to do is you need to just find the factorial of a particular number. And then when you break down your code and try to rerun it using your debugging techniques, dry run the code, you'll get an idea of what is a recursion. Factorial. So basically, we need to find the factorial of 5. This is your question. The code, whichever code you write, I'm pretty sure will trigger the recursion only. If needed, we'll do dry run, but first write the code. Hope the answer is very clear in front of you. Yeah, whichever code you write, no matter whichever approach you go, you will go through factorial only, I'm pretty sure. Let's wait for others to do it, then we'll do it all together. Okay, so now let's try to do it together. I guess some of you have already done it. So static int fact, it will take a integer n. If n is less than equals to 1, at that time you return 1. Again, now we are going a bit mature code. So this is your base case. Or else what you do is you return n multiplied by fact. It's going to be outside this. Yep. Now it's correct. N minus 1. So you minus number like 5 will be 4, 3, 2. And that way you move ahead. This is your recursive call. You're calling it recursively. So now here we come, and I believe it should be outside the main method. Yeah, now it's correct. So in the main method, we should call it. So and what wrong am I doing? It's not giving auto suggestions. System.out.println. Oh, my finger was on function button. My bad. Factorial of maybe I want just 5. So it should return 120. Okay, it's error. It should be out. So 120 into 5, 12, 5, 7. If I write 6, it's going to be 720. And if I write just 7, it's going to be much larger number, of course, in thousands. So let's keep it 5 only, 120. So is the Question understood? For int I is equals to n, I is less than equals to n. Okay, factorial is equals to factorial times I. Yeah, that is also correct, Pallavi. Good. So you can have multiple ways, but now our fact here was to make recursion understand. So here we are using recursion. If I call this one I is less than, if I call here 0, for example, if I put here 1, so it's one, this one should give us answer as 1 only. And then if I call here 0, again it's giving us 1 because we are handling the base case as well. Or else any other number that we use, maybe 20, it's going to be a very big number, maybe in millions. It's coming in the negative because it's out of the range. Maybe if I put here 10, then it should be working. Yeah. So if you do 10 into 9 into 8, 8 into 7 into 6 into 5 into, again, if you debug this code, you'll get an idea what is factorial and what is recursion, basically calling itself again and again. So is recursion understood? This is an example of recursion. Calling itself again and again. Fine. Especially Abdul, have you understood, sir? Fine. Fair enough. Good. So again, we are not going into very much details of everything, but of course, first we'll try to solve the simple questions, then we'll go with the more complex ones so that it's easy for us. So now let's come here and go with linear search and binary search. So this code might be a big demo. So basically what we are going to do is, first everyone knows what is linear search and what is binary search. Again, we were on this topic yesterday, but we could not cover linear search wherein you travel line element by element. You have O of n, O of n, that is your fixed time complexity, and binary search is O log n when your data is sorted and the array is very big. Binary search is also called as divide and conquer. If someone doesn't know, please ask me because we'll be using this thing again and again. Yeah, I have put it in the chat box. Linear search means you do traversal of your entire element in the array. Your data is not sorted in linear search. You have O of n as your time complexity because you go through each and every element and your array size is usually smaller. The data size is smaller in linear search, but when it comes to binary search, your data is sorted and it's all much bigger than. True, very true. Krishna has said very true. So in linear search, we have to traverse each element, but binary search, we divide the array into two halves and do searching in one half recursively. Exactly correct. So basically in your binary search, you always have sorted data. It works only on sorted data, and the data is quite bigger in binary search as compared to linear search. Right? So I'll be writing a code. You can write along with me. Again, we are just seeing the use case of it. Then we'll go with the here n into fact n minus 1. So it will go until the last element. If I don't do n minus 1, it will count that element also. And you can see you get an error. Somebody was asking me what is the last line of my code. So that's the reason I did it. Stack overflow because it is not ending only. It is going. So I need to do n minus 1. N is my 5. If I don't use this minus 1, of course, it's calling itself again and again. There is no end to it. And then we get error. N is my number here. Again, if you do a dry run and debug of this code, you'll get a very better idea of what this code is. Basically, we are getting multiplication of the numbers that are below than this. But when we go for this number again, so it is calling this number again and again, and then there is no end to it. So if you see 5 into 4 into 3 into 2 into 1, we are not doing 5 into 5, 5 into 4, 5 into 3. That is the error. Okay, madam. As 1 minute, I wrote it in the chat box somewhere. Yeah. 5 into 4 into 3 into here. What we are doing is 5 into 5, then 5 into 4, then 5 into 5. It's iterating again and again. So we need to stop it. I guess Abdul knows it. LMS portal is free for everyone. You can access LMS portals. I guess this session is also getting recorded, so you'll get the videos over there. So now let's move out. And then before we go with anything, let's have first a search or demo class. I'll just be coding it. And I did a spelling mistake. SCA search sort demo. So here we will have linear search, binary search, everything. Binary search means we divide it into two and then we get the result. Maybe if my target is 200 and I have an array from 1 to 1000. So what we do in linear search, we'll go by each and every element. We'll go with 1, 2, 3, 4, 5, everything. But then in binary search, okay, let me open Paint or maybe Notepad only. I can explain this in Notepad also, I'm pretty sure. So maybe what happens here is in linear search, we go through each and every element. Traverser, go through each element. So you have O of n. So maybe I have my data wherein I need to find my target is 200. It's number 200. So basically what happens is I have a data wherein I have 101, 199, 378, 200, 450. Maybe this is the data that I have in my array. No, you don't need to submit any assignment on any website. Your attendance is sufficient, I guess, just to get certificate. Attendance, yeah, good evening, Kavita. So in linear search, what you do is you go through each and every element, and then of course, first you come here, then you come here, then you come here, then you find it. Okay, you tell you it's on third index, and then you don't need to check it. But your complexity would be O of n because you're going through each and every element. So time complexity would be O of n. But in binary search, your condition is data is sorted. Again, our data would be something like this: 101, 105, 109, 145, 199, 200, 210, 299, 302, 310, and we can have much more data. So now what happens is in your binary search, what happens is you first see, okay, your data is already sorted. So first you see elements, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the midpoint would be 5. Okay, let me do it. One more here. Okay. So since I was taking random numbers, like randomly, so here you come and tell 1, 2, 3, 4, 5. Here you have 1, 2, 3, 4, 5. So you set the midpoint. So your target is again 200 only. So now you search for elements that are 199, 200, 210, 299. This is your second iteration, okay? 302 and 310. This is just an example. So you see you have removed the half of the elements already because your data is sorted. Again, here you come and again you divide it, your array here into 3. So then you come here and here you get 199, 200, and then 210. That's it. And then you see, okay, fine, on middle you find 200. So maybe here if we get O log n as the time complexity here. We are not going through all the elements. We are dividing it into 2. And this is also called as divide and conquer. Is the theory understood what we did and how we did? In linear search, you go through each and every element. Maybe if we have your 145, you'll have to traverse through that also. 198, you'll have to traverse through that also. Again, you will have your some random numbers. Your data is not sorted here. You can have 451. Again, in linear search, you'll go through each and every element. So you will go through each and every element, but in binary search, your data is sorted. That is first condition you can see. We don't have any ascending, descending number combination. We all have ascending numbers only. Starting from small numbers, we are going till big numbers. So here you see the number of steps you require to go till 200 is you take 1, 2, 3, 4, 5, 6, 7 steps. And here you take 4 steps, although your data here is bigger than the data on the top. So now we'll write an example and then we'll solve some questions on linear search and binary search. And maybe after that, we'll see sliding window. So let me write the code. Search sort. We will see insertion demo. We'll see binary search demo if needed and linear search. That's it. Again, you have bubble sort and many things. We will not be covering all of them. So in our main method, let's have it. The code execution. We have an integer array again. I'll not be taking a very big example. Maybe 5, 2, 9, 1, 3. Only 5 elements. Okay. So this is my integer array. Yes, we have done. Yes, sir. When you traverse through each and every element, we know we have done recursion, we have done linear search. Exactly. Yes, yes, of course we did it, sir. But then people were not aware that this is linear search. So I need to iterate things so that, of course, anything you do repeatedly, you'll understand. So we'll have a linear search. Maybe in linear search, we'll put some logic in one question only. Then we'll have a binary search as well. So you get an idea for this question only. And then, of course, we will have sorted one also. We'll have to sort the array. So let's write some methods. I'll put some comments also so you get an idea of what I'm doing. So linear search. Static int linear search. You go through each and every element here in your linear search. And let's try to see what we'll do. Int of array. And then we will target one key, maybe any number. We want to find that number, but using linear search. So we'll use for int I is equals to 0, I is less than array dot length, and we will increment the I. We'll tell I plus plus, and here we will tell for if array of I is equals to our key. Key, of course, we will define it. At that time, you return I. If not, then you return -1, -1. Key is not found. Okay, so now this code does not make sense unless and until we don't call it. We have an array here. So let's try to call it and then let's make this one sense. So I come here and tell system.out.println linear search, and I want to find the element. So maybe I want to find 9. Already it's there. So let's try to find 9 only. So here we have plus I'll call my method linear search and array of 9 key. So now this one should print the index. So it's at second index. Here you can see why it's showing second, because 0, 1 and 2. It's at index number 2. If I try to put the key as 3, this one will search 0, 1, 2, 3, 4. 4 should be the index. Yeah. But if I try to print the number that is 5, okay, 5 not 6. This one should return -1. Of course, here we need, this is hard coded one. So we need to change that, of course. Find 6. This is hard coded. But if I try to find 2, of course, 2 is that first index. So it should return 1. Is this understood? Because I'm going to club 2 or 3 codes together. Is this clear? Then of course we'll go with the insertion sort to sort the array and binary search as well. Fine. So linear search is done, I believe. Anyone having any doubts, ask me please right now. Fine. I guess yes is more common now and I'm happy for it. So now let's try to go ahead with the next part. Okay, sure. So 1 minute, I guess. Dhruv says no, sir. Dhruv, is there any question here? Not understood? Something like that? Okay, fine, fine. Thank you, Dhruv. I'm happy. Fine. So now, so first we need for binary set, what was the condition? If we go to our notepad again, data is sorted. This is the first condition. That is the rule for binary search. If your data is not sorted, binary search is not possible. So first we need to sort the array. So I'll come here and tell. I'll be using insertion sort to sort the array. Again, I'm trying to use less inbuilt methods since we are at the learning stage. So I'll come in and tell static. Oh, static void. It will not return anything. Insertion sort. And this one will also take an integer array. And let's have some logic defined for this also. Arrays dot sort, if we do, it's going to be sorted automatically. Again, I'll provide the notes, but then that comes with experience, Abdul. But don't worry, I'll try to provide as many notes as possible. For int I is equals to 1, we'll start with the 1, of course. I is greater than array dot length, and then we'll increment the I, and let's write the logic behind it. Int e is equals to array of I. You go to each and every element of your array, and then we'll take one more element. Int j is equals to I minus 1. So we'll have one number less, while j is greater than equals to 0. Sorry, greater than equals to 0. Not, we're not comparing it, sorry. And array of j is greater than key. Each element is greater than key. It should be greater than 0, and the since we have started it with 1, key is equal to array of I. So we are seeing that if it is greater than the element in the array of j, each element. So we write array of j plus 1. We are incrementing the value is equals to array of j. And then we are going to decrement the value of j minus minus. Fine. And we'll write array j plus 1, assign it to the key. So we are taking a full round lap. If we go through the code, it's on LMS Aryam Singh, not XLR website. Your LMS will have notes, dear, and videos. So we are going through everything. First, we are telling that I is equals to 1, I is less than array dot length. So it's going to be array dot length less than that, and we'll increment, we'll go through each and every element here. Then we have assigned a key as integer, and we are giving array of I as key. So whatever elements we have, we store it in the key. Then we have taken one more variable, j is I minus 1. So it will be less than the I value. While loop, we are checking j is greater than equals to 0, and array key j is greater than key. You do j plus 1, assign it to value of j and decrement j. And then after the while loop, since your while loop is ending here, you do j plus 1 is equals to key. So now, after this, so here, if I come and do insertion sort, and array. So maybe if I try to print this and show you, and I guess this one will not get printed on its own, I believe. This one is showing some error. The print method Boolean, okay, fine. Since it's a Boolean, no, it's static. Yeah, it's not returning anything. So if I return, but of course, returning an array, okay, it's not returning anything, so we'll not be able to print this one. Since it's void, void do not print anything. Void means it does not return only anything. But then once we do the next code, you'll get an idea. What is the value of array of j? Fine. So array of j will have everything sorted. Here we are sorting the data. Again, let's have a binary search, and we'll use this one as an argument there. So you'll get a clear idea. So here we are doing the sorting technique. We are using sorting the data. Since it's not returning anything, void means does not return anything. If it does not return anything, we cannot print it. So now let's have a binary search. Of course, for binary search, this is just a demo code. We will have one more code on binary search. So binary search. First, this code is written to sort the data because our data is not sorted. We should have 1, 2, 3, 5, 9 as our data. So it was static int binary search. So here we have an integer array, and we have integer key here. So here we have int low would be 0. Since we divided 2, we will have int high. We have one low point, one high point is equals to array dot length minus 1. So we go till the last element. So if we have numbers here, for example, I is equals to 0 here, and length minus 1 will be here. So we go from here 101 till 310. This line of code says like that. So now here we come, and then we tell while low is less than or equals to high. You check, compare low to high. So we want a middle point. So we will tell id middle is equals to low plus high. So we get a number, you divide it by 2, so you get an average. For example, if you have 5, 10, 15, 20, so you check 5 and 20, that is 25, 20 and 30, 55, you divide it by 2. Low plus high divide by 2, so you get a middle point, a midpoint. So if array of mid, if that is equals to the key, if we find our key there, at that time what you do, you return the mid. If you find the key there, return the mid point number or array, whatever we are asking, index. Else if key is fine, yeah, we don't need a curly brace, I guess. Else if key is less than array of mid, if you have your answer in the low range, at that time what you do is you tell high is equals to mid minus 1. If that is also not the scenario, then you go with the else part, and then you say low is equals to mid plus 1. I guess this one should be round bracket here. So if you see this code, in simple mathematics, what we have said is first you would see low is less than equals to high. You do low plus high divide by 2. Whatever you get, if you find that, you give the mid. If key is in the less range, you go mid minus 1. If key is in the greater range, you go key plus 1. And then of course you need to do return minus 1. If you don't find anything, you do return minus 1. Okay, and 1 minute. I did a mess up, I guess. Okay, this code is coming till here. It's the method should be ended here, I guess. Yeah, now it's correct. This is your while loop. Okay, control A, control I, fine. So binary search is still here. Okay, while loop is still here. Our class is still here, fine. 33 and 34 line. What is there, Abdul sir? Yeah, it's we are going either to the low part or to the high part. So now let's come here and let's try to call this in the main method and see. Again, we'll take the array from our example as well. So now here we come and tell binary search example. So binary search, of course, it's done. So sorting for binary search, I should write like this. Sorting for binary search. And now here we have our binary search example. So I'll write system.out.println. And here if I come and tell binary search, and we need to find 3 here. So here we come and tell binary search array 3. So since it takes a key, so we have it here. So see, it says binary search find 3. This one found it at the second index. Now you'll see why second index, 0 index, first index, second index. You see our array, original array is this. So now in order to show you how it's working, print sorted array. First, is this answer understood why it came? If I'm putting 3, if I put 5 here, the index should be 0 index, 1 index, 2 index, and 3 index. The index should be 3 here. If I try to print 5, the index should be 3 here. And 1 minute. Okay, here it's not there. Okay, fine. First, is this understood how it's coming? Exactly, correct, Abdul. So now let's try to print the sorted array. Print sorted array, so you get an idea. So I'll be using sorted array. And then I'll be using a enhanced for loop for int I in arrays. If there is a space, so I'll use print only instead of println. Since this one was void, we are not able to print it. Now we are printing it also. And see, our array is now this sorted array. Our original array, you can see here, it was this. If I want you, I can show you this also. So if I come here into original array, or int I in arr, attendance link will be at 8:30 Maisa for each loop. And then here, maybe if I come here and just see, our original array was 52913. You can see here. But then we did a linear search to find, and then we found using binary search. We did a sorting, and after sorting, it became 12359. Hope there should not be any doubts. If there are still any doubts, please feel free to ask me. You can see the code. You can go through the code. Then we will have an example of binary search now. So line by line, the code gets developed. Control A, Control I, so that it's formatted. So first we went through linear search. Go through the code maybe for next few minutes so that you get an idea. Here we did the sorting part. Then here we went for the binary search. And then here we call the methods. So now, on the basis of this, you will have a question on the binary search. And of course, you will understand recursion also, because binary search behind the scenes uses recursion. When I say binary search uses recursion, how many of you agree with me? Binary search uses recursion. Okay, it will break the array into half. Again, it will go through it. Again, in the half, again go through it. So you will see your code will always be looking like this only. It will always look something like this only all the time in the world. In simple words, you are taking some one complete thing, breaking into half, checking your target is in the first half or in the second half. First, you are checking, do you got it at the center? No, it's in the first half or second half. It's in the first half, leave the second half. Your 50% load is finished. Or you go for the first half, or you go with the second half. So now, on the basis of this, we'll come here and binary search recursive. Now we need to use binary search here, and then we need to find something. So let's have a main method in this. Yeah, fine. So we'll have an integer array, and here we will have data. Of course, we need sorted here. So 5, 10, 15, 20, 25, 30, 35, 40, and 45. These are the numbers. Okay. Here you can see they're increasing by 5. We are not at all interested in that. Our int target is 35. This is our target. Fine. And you need to find the index of 35. Return the index of target using binary search. That's your task. Please, is the task clear, everyone? Yeah, please do it. Take your time. Take time to build logic. That is fine. Yeah, please do it. Go with binary search. Don't go with linear search. We'll wait for 2 minutes. If you are able to do, well and fine. If not, we'll try to do it together. Okay. Okay, so now let's try to do it. Now we all have our own ways of doing it. I'll be making a method as always. Static int binary search, and it will take an array of integer, and it will take a start number that is also integer type, int end, and of course our end will be target. So we have defined the variables. Since we are not returning any int, so this one is telling us that it's an error. It will go once we do coding. First, we need to see if it's sorted. If start is greater than end, at that time you straight away tell return -1. We don't need to go with the condition also inside here. Straight away tell I'm not going to do. Data should be sorted. That is the first condition. So here we have said if start is greater than end, you return -1. Don't go with it. It will return -1. If we want, we'll do it and see. We'll make some changes. Maybe we'll make this one 50 and see. This one should return -1. If that is not the case, then our midpoint, what it would be? It would be start. We don't know the numbers as of now. End minus start. BODMAS rule. Are you all aware of BODMAS rule? What is BODMAS rule? Bracket open, division, multiplication, addition, subtraction. Precedence that is given. It's always in the bracket first. Yes, fine. So first it will sort the bracket. End would be here. Start would be here. End minus start divide by 2. So we are dividing our array into 2. So there we'll do addition. End minus start will be there. Then you will divide it by 2 and then you will add it to the start. So you will get a midpoint. If you want, you can use your calculator and do it. You'll get an idea. Simple maths. Low plus high, of course, you can take. That is also good approach. After taking start end, you can take low high. That is also fine. Low means your start. High means your end. Variables can be anything. So again, if else would be common here. No matter whichever code you see, if you are using binary search, you will get a if else condition for sure. If mid is equals to target, if at the middle only we get the target, maybe our target was 20 and we break, we get the target as 20 at the middle only. At that time, what you do is you straight away return the mid. Again, I do have a habit of putting curly braces. I need to get out of it. So you return the mid, simple. If you get it in the middle, just return it. In case you don't get it in the middle, else if you're not, then what you need to do? If array element of mid, like all the elements you see is less than target. So of course you need to go at the left part, smaller numbers. Then you return We call the method recursion, binary search. Our entire array, mid plus 1, and target. If you don't get in the middle, if array of mid is less than target, you call the method binary search. The entire array, mid plus 1, you go to the higher end. If not this also, then you do -1, of course. So we come here into else, return, binary search. Why binary search? We are calling the same method that we have on top. It's binary search. We are doing recursion as well. So then here we come. And then we'll tell array mid -1, not +1, but then we go to the opposite direction. And then first we need to go with start, because we are going with smaller one. And then you go with the target and a semicolon. Fine. So now I believe this logic should work. Let's try to see it here. We call that our main method integer index. Since we want the index is equals to binary search, we are calling the method that we have defined at the next just below, and it will take array start from 0. Fine. And then what I need to do is array dot length -1, and would be my array dot length, and then target would be my same target. Fine. And now I'll come in and tell found at index plus index. So after this much of hard work, let's try to see are we on the right track or not, which I believe I am. Our target is 35. So 0, 1, 2, 3, 4, 5, 6. It should tell 6. Yeah, it does. If I put it 0, 50, it should return -1, I guess. 1 minute. Target is 30. And if start is greater than end, fine. Okay, so it's removing it. Since it's dividing into 2, that is not coming, it's returning -1. But then if I change it to 25, this one is showing 6 index. If I put here 15, this one should tell index of 2. And if I do 50 now here, since this falls in the bracket of that window, again it says 0, 1, 2. Binary search, it's starting from 0 index. And why is it happening like this? It says -1. Okay, it's seeing just the immediate number. -1, yeah. If this one is maybe 20 only, then also it should return -1. Yeah. But then if it is 11, it's fine. But even for this, I need to check why, since this start is greater, this one should return -1. Why is it not returning -1? Anyone, any idea? At 0 index, if I'm putting 50 number, why is it returning? What is the logic behind this? Because here if I'm putting, technically, this code is wrong. It is not sorted. It should not return. What is the reason behind it? Anyone have any solution for this? Is the question understood? Fine. Unsorted. Yeah, exactly. No, no. See, the thing is here, if I put here 5, okay, if I put here maybe 14. So this is unsorted data. So this one should return -1, but it is not returning -1. This one is returning 2 index. But if I put this one 22, now this is unsorted. Again, this is unsorted only, but it is returning -1 here. But here when I put 10, again this is unsorted data only. Here you can see 14 is there, then 10 is there, then 15 is there. Ideally 10 should be before 14. So it should not 1, it should return -1 when start is greater than end. But still it's returning 0, index of 2. Is the question understood? Why is this happening? Again, this is unsorted. This is not a sorted data. If you see the data here, you have 14, 10, 15, 20. This is not sorted. 14 is greater than 10. But still it's giving us the correct answer. Why? I want answer from you. Again, if needed, we can go to internet. That's fine. Okay, it's neglecting 0 index. It's less than mid value. Mid value, mid value, mid value. Okay, let's see. 0 index is ignored. Mid value fine. Let's see here only. Why do data at 0 index in binary search is ignored? It's just by chance because when dividing into half, 15 less than, so first searching element, next middle element 15, and thus it's found. Fine, okay. No, here in this scenario, we start from 0 index, of course. So what we do is it will divide it into 2 parts. So, okay, let's try to make data haywire, maybe 50 here and then 80 here. And then let's try to target maybe 50. So this one should for sure, no, okay, let's try to target 25. And this one should give -1. See, but it's still telling index at 4, 0, 1, 2, 3. No, it says 4, 25. Okay, 0, 1, 2, 4. It's giving correct answer, although the data is not sorted. So maybe here, if these elements are coming here, these elements are coming. No, I guess there is something wrong with the implementation. Start from 0 index because it's found directly at mid position. Okay, it's finding directly at the mid position. You are telling that. Okay, so maybe if I put here 35, now 35 is not at mid position. Still it's giving 6. 0, 1, 2, 3, 4, 5, 6. Attendance sheet is ready because okay, Krishna, your answer was correct in previous case, but now what about this one, sir? Students, attendance link is there. Please fill up the attendance. Attendance link is already there. Please fill up your attendance. Then we'll come and find the solution for this one. You have 2 minutes of time. Please fill the attendance. Fill the attendance. It's not necessary, will always give. Exactly, Krishna is getting the point. So basically, what happens is, see what it is doing is, this one is checking the midpoint. See, binary search means it's checking 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's checking from here to maybe here. This window it is putting and it is checking, or maybe till here also it's going. And we have 4 or 5 elements, for example, 4.5 somewhere here. So it's checking is start greater than end, 14 is greater than 50, no. Or 14 is greater than 25, no. This is checking this condition. Then it's returning -1. For example, if start only, I'll put 210. Try to understand the same. So now if I run it, this one is again showing because it's getting with the target now. So maybe now, first let's see. Does binary search needs to be sorted data? The answer is yes. Yes, a binary search requires the data to be sorted in advance for the algorithm correctly. So if you don't get the answer correct, maybe your data is not sorted. So here you can clearly see that you need your data to be sorted. It eliminates the halves. Divide and conquer it is called. Failure of unsorted data. If the array is unsorted, the elements on the left or right of the middle elements are not guaranteed to be smaller or larger. Therefore, discarding half of the array could accidentally eliminate the target. So you may get the result, you may not get the result if the data is not sorted. Is the question answer understood? Anyone any doubts in the answer? You may get, you may not get the result. It's not guaranteed. Is it clear, students? So if I try to target 55, see it returns -1 because 55 is not there. If I try to target 52, again it will return -1 because it's not there. But then if I try to target 80, see it returns -1 again. Although 80 is there. But then if this 80 was in the sorted part, then of course it will return the index 8. So is it clear, students? If your data is not sorted, you may get result, you may not get result. You may not get accurate result. Fine. So now let's go with the sorting. This is binary search done. Let's go with a couple of sorting examples. Sorting is pretty much very simple. Like we need to sort like we do manual sorting. In the same way, we need to do it in programmatic way. So we are going to sort alphabets. So here we come, and all we need to do is okay, Aisha, don't worry, you will get a call or message maybe if not today, by Monday or Tuesday. Form was filled up, your job is done. The counselors will do their job, they'll call you. Recording again, and one more thing, did you got the notes on LMS? Maybe just a PPT and some roadmap on LMS. Of course, few more notes will be shared with you. But did you got it? In your LMS, did you got the notes, the PPT that I shared with the what is big O notation, time and space complexity? Has anyone checked it? If not, please check it. I believe your notes would be uploaded. In case they are not uploaded, please get in touch with me. I'll ask ma'am to do it. Of course, she might have done it also by now. So now string s is equals to hello world. Right? So I want this one to be sorted. Means what comes first? A, B, C, D, E, F, G, H, I, J. Okay, it's going to be D. So in that way, hello world should be sorted D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W. So, so is it sorted now? D, E, H, L, L, O, O. Fine. Hello world. H, E, L, L, O, W, O, R, L, D. Yeah, I guess it's sorted. But I want you to write the code for it, wherein you sort everything according to the word, the way they come in English. So first you get D, then E, then H, then L, L, O, O, R, W. Correct me if I'm wrong in spelling, but then of course I believe this is the correct solution. Is the question understood? Please try to find the solution for it. Convert it into array or do something. Char array. Yeah, good Jatush. Let's wait for others to do it. Okay, so now let's try to do it together and see. Of course, as I always say, we have multiple ways of doing it. I'll be doing it at a very beginner friendly way. Of course, some convergence will do. Fine. Convert the string to a character array. First, we'll convert the string into a char array. So I'll write char array is equals to s dot. Why s? Because s is denoting to this string to char array. Fine. So if I try to print this s, so again is, if I do char at 0, it's going to just print h, char at 1. Again, it's a string only. But then, of course, just to show you, I've converted it into array, and each character, as you can see, is now getting printed. So now we can at least see that each character is getting printed, but then we have converted it into an array. Then what I'll do is sort the characters in array. So I can use a for loop, or I can just use arrays dot sort the array. So this one we get java.util package, and we are sorting the array. We are sorting it by A to Z automatically using the inbuilt sort method. And then after that again, convert sorted characters array back to string. So for that, I'll be using s is equals to new string of array, and then I don't want it on entire line in the same s. So now I believe if I run the code, okay, this one is coming from here, we don't want it. DEH. Okay, there are 3 L's, my bad. Here I don't know, only 2. So is this understood, students? Anyone any doubts in this? Of course, we all have our own logics. I don't say that this is the correct one, only correct one I can tell. But of course, you can have your own way. Fine. So now one last code for the day. Should we do it, or maybe we have still 12 minutes, 12, 13 minutes. Should we do it, or should we go with some theory part? Theory or code? You can put it in chat box. Theory part. Khushi says theory. Jatush says code. Ridhima says theory. Shubham says code. Abdul says give assignment, sir. Okay, fine. So now let's not go with everyone's point of view. We can have at least find code. Okay, fine. So I'll go with the theory and then give you a code as assignment, and then you need to do the code. Okay. So fine. For those who are willing to do code, sort string by words. I'll give you a string. You need to sort it by words in ascending to descending and make a sentence out of it. Then we'll go with the theory part, of course. Theory, yeah, of course. Those who want to do it, do it. Those who don't want to do it, your choice. We'll do it together, okay? You need to use comparator as well. We have a string here and it's an array. And I'll just put the string so you understand. First word, maybe I'll put Mumbai. Second word, I'll put I. Third one, I'll put maybe the state name Maharashtra. Of course, I am not from Maharashtra, but sorry, I am from Maharashtra, but not from Mumbai. I stay in Pune. So now I'll put from and am. Since I did not write Pune because from and Pune would clash. So this is your string wherein you have words and you need to give me an output that should say I am from Mumbai, Maharashtra. Is the question understood, everyone? What is the question? Of course, I'll be doing the code for it tomorrow. Yeah. You need to have answer like this. You have already given a string, sort string by words. So you need to have the smallest word that is only just one alphabet at the first. Then you have a bigger alphabet. So am will be coming here, from will be there. Yeah, please Xiaomi ask question. If you have any question, please Xiaomi, you can ask the question. And now let's go with the theory as promised. Of course, I believe this is understood. So now this PC, XLR DSA, and then of course DSA nodes. Let's see what is there in the theory part. Fine. Remove duplicates or maybe two sum. Yeah, of course, two sum is also one of the important questions. So linked list, of course, linked list and all will do later on. So basically, I would request you all to come prepared with these topics also. Some hash map is there, linked list is there. Okay, let me see. Do we have hash map or not? Fine. So we'll go with the theory of hash map. So what is an hash map? Do you know? Map does not store duplicate items. Yeah. Map is a data structure in collection framework that does not allow duplicate items. Yeah, key value pairs where keys are unique exactly. So we'll be going with that. You have these many questions on the basis of this binary search. Okay, binary search and all. Let's do it. Sliding window also we'll see later. We use binary search to optimize our search time complexity when the array is sorted minimum, max, and has a definite space. It has some really useful implementation with some of the top companies still asking questions from this domain. So here you can see your low, mid, and high in a sorted element. The concept is if the array is sorted, then finding an element shouldn't require us to iterate over every element where the cost is O of n. We skip some elements and find the element in O log n time. So this is the heart of the binary search. If you go with the linear search, your time would always be O of n. But if you go with the binary search, you are hitting O log n, and O log n is shorter than O of n. So algorithm, we start with 2 pointers by keeping a low and high, finding the mid and then comparing with that with the number we want to find. If the target number is bigger, we move right. As we know, the array is sorted. If it's smaller, we move left because it can be on the right side where all numbers are bigger than the mid value. So this is the theory for it. We write if, else, if and else statement. Right? Here is an iterative and recursive way to write the binary search algorithm. If left is equals to 0, right is equals to a dot length minus 1, loop till the search space is exhausted, while left is less than equals to right. Right? So you'll always see left plus right or low plus high divided by 2. If you see this, you have your binary search. Binary search works only on sorted data to get best results. And of course, your array size is very big in binary search. Right? Here's a beautiful visualization to understand it even more. So basically, let's understand the recursive solution now. We call the function for the left side and right side. If the mid doesn't match our target, we can either change the left or right pointers through the argument or through cases. Argument looks like an easier way. If we want to move to the right, we change the left pointer to mid plus 1. And if we want to go left, we change the right pointer to mid minus 1. Very simple. So here is the whole thing. Now this is, I guess, a Python code, but of course, if you see, the logic is same. Instead of else if, we write elif in Python. Check the base case. Then you go with the midpoint. Then you go with the binary search, either less than and greater than. So basically, max font size, Google internship. For Google internship, there was a question like this. You can read this question because, of course, you make different size devices, program working, responsiveness websites. So for that, we use this one. Google likes to test you on word problems like core principles. So even if you ask for a binary search question, it will be framed like a real life thing so that it's much harder to understand. So this is a binary search question, but in real world scenario. They also test OOPS sometimes. OOPS basically is object oriented programming. You have inheritance, encapsulation, polymorphism, and abstraction. Abstraction, inheritance, polymorphism, and encapsulation. So by asking you to create classes and functions to display different things, here's the question. Given a height and width of a screen where you have to type, height and width of each character you type on the screen, min and max range of the font size of each character. So this, if you see very closely, is binary search wherein you have min and max size. Find the maximum font size such that the character fits in the screen. So if you want, I'll paste this for you. And I'll not be giving you Sudoku. Just remember, it's page number 19. Once you understand the question, it's traveled to think of brute force solution. Brute force means you have only one solution. That is the hardest one, maybe, and it takes a lot of time to solve, but it's fine. Brute force means whatever comes in your mind, you do it. So I'll paste this on the notepad. This was asked by Google company. Of course, we all know what Google is. Google needs no introduction. Okay, and why is it giving solution? I did copy something else. I copied this one, correct? Copy. Yeah. And for tomorrow, if you want, try to get the answer maybe on Monday on this. You can see the attendance sheet is already shared, students. This is the question. Of course, I have taken it from notes only. Binary search we have learned, and this is the Google internship question. You can take a photocopy of this if you want and try to find the solution. And of course, there is one more question given as assignment. And that question is this one. So maybe I'll paste this both here in the chat. You can take a photocopy of that if you want. So students, anyone any doubts in any of the concepts? Again, we'll see sliding window, sorting some questions maybe in next session. You can take a photo of this and then we are done for the day. If there are doubts, you can ask me, or else we are done for the day. If you have doubts, put it in the chat box. Thank you, Khushi. Thank you, Nisar. Okay, so we can end the session. Okay, Sushmita ma'am.
Thank you, sir. And as tomorrow and day after tomorrow, that is a weekend, so we don't have any session. We are again meeting on Monday, sir.
Sure, ma'am. We'll be meeting on Monday. Okay, students, make sure you do the assignments. Thank you, everyone. Bye bye. Have a good weekend.
Yeah, so dear students, as informed, Saturday and Sunday we don't conduct any session. So we are again meeting on Monday. So I request please everyone join the session on Monday at 7 p.m. So we'll be winding up for the day. Thank you all. Thank you for joining. Good night.